Have you ever wondered why some neural networks train slowly while others zoom through? The secret lies in a technique called batch normalization, which recenters inputs to stabilize your entire model. In artificial neural networks, training can become unstable as layers output values that drift wildly. Batch normalization solves this by acting as a design pattern that normalizes inputs to each layer, keeping them within a predictable range even when earlier outputs change. The core mechanism involves a transformation that maintains the mean output close to 0 and the standard deviation close to 1. This recentering and rescaling process effectively resets the distribution of data entering every layer, preventing the model from getting lost in its own gradients. Interestingly, this technique works differently depending on whether you are training or inferring. During training, it uses the statistics of the current batch to normalize data, which helps stabilize the learning process as it progresses through the data set. By keeping inputs in a stable range, batch normalization allows you to use higher learning rates without causing the network to diverge. This is essential because it accelerates training significantly and improves overall performance on complex deep learning tasks. Without this stabilization, the issue of internal covariate shift would slow down your model. Batch normalization ensures that the inputs to each layer remain consistent, making the training process not only faster, but also more robust against changes in earlier layers. Ultimately, this technique turns chaotic training into a smooth journey. It is the key to unlocking higher performance and faster convergence in modern deep learning architectures, ensuring your model learns efficiently from the start. So there you have it. Batch normalization stabilizes inputs to make training faster and more stable. What other deep learning tricks do you think are game changers? Let me know in the comments.